Hey everybody, this is just a quick tutorial for the CER that you took in class on PS2 Learning Set 2. And if you're wondering which one was that, well, it was one with where you had to figure out what was happening at diagram 3. So again, this is just to be a quick tutorial. I'm hoping to have the video under 10 minutes, but if you're still struggling with CERs, don't give up. You can do it. And this video will help you with future CERs. So remember, a claim is a statement about the result of an investigation. And a claim is just one sentence long, where every once in a while I'll have someone write me a full-size paragraph for the claim. No, just one sentence. So what is your sentence going to be about? Well, you're going to answer this question. Which energy conversion diagram is the best example of a tennis ball at position 3? So you might be wondering, okay, Mr. Ratu, if we're talking about the claim, why do you have scientific principles up here first? Well, sometimes it's easier to go through and look at the evidence and look at the scientific principles first to see which ones will help us. So what I'm going to attempt to do is I'm going to attempt to justify and figure out which ones these are first. Now, let's look at them. Here you have KE going down, KE going up. KE going up, GE going down. Now you notice that these are the same, except now they have EE in it, elastic energy. So if we were to start to take a look at which ones are appropriate, which ones are not. And again, we want to find it for position 3, because that's what it says right here. So any moving object has kinetic energy. That is true. All these are going to be true. All the scientific principles are true. But which ones will help support what we're trying to accomplish here? And that first one is great, but we don't need it. This one has KE, this one has KE, this one has KE, this one has KE. They all have KE. They're all moving. So this one doesn't really help us at all, other than it says, hey, they're all moving. They all have KE. Well, we know they all have KE. We know they're all moving. Number 2, an object's kinetic energy increases as its speed and/or mass increases. Okay, so if we want to start to figure out what's happening here, we know it's going down. So if it's going down, what's happening to the GE? Well, as it loses elevation, the GE should be going down, and that energy is being converted to what? KE. So GE is decreasing, and what's happening to KE? Going up. So it's either going to be this one, or it's going to be this one. So this is a good one. An object's kinetic energy increases as its speed and/or mass increases. So here it says KE is going up, and we know that objects that are falling increase speed because GE is being converted to KE. Let's look at 3. Any elevated object has GE. So much like 1, we don't need this one. They all have GE, so we know they're all above the ground. This one, you can make the argument wouldn't have GE, but we're trying to find the best one for position 3. And all of these have EE. So 3 does us no good. But 4, an object's gravitational energy increases as its elevation and/or mass increases. Okay, so now we're talking about GE. You might say, well, it's not increasing, it's decreasing. Remember, these can be flip-flopped around. So if KE is going up, GE has got to be going down. So again, we know it's 1 or 2 or 3. So let's cross these off. We know it's not going to be because of these 2 scientific principles. 5, energy can be converted. Yes, we know that. And it's happening here. They all are. It doesn't distinguish one from the other. Any deformed rigid object has elastic energy. This is crucial. This says if this ball is deformed, it has EE. So 3 has EE. So diagram 3, not position 3. So diagram 3 has EE in it. But would the ball at position 3 have any EE? No, it won't, because it's not in contact with the ground yet. It's not deformed. So now we know for sure it's position 2. So an object's elastic energy increases as its deformation or rigidity increases. Doesn't matter. We don't need it because it's not deformed. Energy can be transferred between systems. True, but that has nothing to do with what we're trying to do, and energy cannot be created nor destroyed. That's true, but it really doesn't help us figure out which one of these diagrams position 3. So now we know it's 2, 4, and 6. So now if we look at the claim, here's a good claim. Energy conversion diagram number 2 best represents tennis ball position 3. Great. Or you can say energy conversion diagram number 2 is the best diagram for tennis ball position 3 because the ball is losing GE and gaining KE. Differences between these: good proficient score, a good advanced score. Now, let's take a look at our evidence. Evidence, we have to start taking a look at things that support the claim. So if we take a look at the claim, what evidence can we take from here that supports it? So we've already decided this is the one. So somewhere in here we should be saying that KE is increasing. So it can't be diagrams 3 and 4 because the ball at position 3 is not in contact with the ground. Is this an absolute must? No, you don't necessarily. You could have it. It's not an absolute. But by saying that, you provided evidence to eliminate 2. So that's pretty powerful. Thus, no EE. So that first sentence eliminates 2. So now you're down to just 2. Now it says also in diagram number 1, it shows that GE is going up and KE is going down. If the ball has been dropped and in the air, position 3, then a GE would be going down because it's getting closer to the ground. So we basically reversed our thinking here and we presented all the evidence to eliminate 1, 3, and 4. So the ball won't have less KE in that position because the ball is let me read that again. The ball won't have less KE in that position because the more it's dropped, the more it gains speed. So is that good evidence? Absolutely. Is that absolutely what you must have? No. You could have written it in a different way. You could have said something like, let me go back up here. The KE is increasing as the ball loses elevation and the GE is decreasing as the ball, or the KE is increasing as the ball is. How about this? Here's a good one to have. GE is decreasing as it's losing elevation and the KE is increasing as it's gaining speed as a result of that elevation, and there is no elastic energy because it's not being deformed. So that would be another good example of something you could have. So let's go right into the reasoning. We already figured out which principles it is. It was position 2, 4, and 6. Now, in order to get a really solid score in reasoning, if you just had one of those, you probably got a developing, as long as everything else was right. You had to have at least 2 of them to get a proficient. And if you had all 3 and everything else looked really good, you could have got an advanced. So here's my reasoning. Again, I'm talking about all 3 scientific principles, and I divided them up by color. Scientific principle number 2 states that an object's KE increases as the speed and/or mass increases. That's good. Now, in this case, the closer the tennis ball gets to the ground, the faster it will go as the GE is being converted to KE. The mass of the tennis ball does not change, so the KE must be going up. So I not only stated the scientific principle, I explained why it was important. We also know, according to scientific principle number 4, that the GE of an object increases if its elevation and/or mass increases, and the opposite is also true. So as the tennis ball drops, it's losing elevation, and thus the GE decreases because the mass does not change. Again, here's my second scientific principle, and I explain why it's important and relevant. Diagrams 3 and 4 are also wrong because scientific principle number 6 says that any deformed rigid object has EE. At position 3, the object that is falling is not deformed and thus it has no EE. So there are my 3 scientific principles, and I explain why they're relevant. So you can't just list them, you have to explain why they're relevant. Therefore, so then finally, we know that there is about 50% KE and 50% GE because the object is halfway between its peak height / speed and its minimum height / speed. Therefore, according to scientific principles, I know that energy conversion diagram number 2 is the best choice for a tennis ball at position 3 in the diagram. So this is my concluding statement, and it's also where I put my claim in this. So do you have to have all this? No. This would definitely be an advanced answer. You only needed really 2 of those scientific principles. in order to get a reasoning, a good score, proficient on a reasoning, but you also had to do the explaining. Just listing the scientific principles is not enough to get a proficient score. So as always, if you are still confused about some of the parts of the CER, make sure you ask questions. I'd be happy to go through this with you. Thanks.